This is a problem of virtual work. If I will see the problem states that we have to find the value of m for this system which is in the static equilibrium using the principle of virtual work. So let's first see the problem. If I will see the problem, I can identify there are three forces: force P1, force P2 and a moment m which is acting at point A. If I will see further, I can identify that the joint A is a pin joint, however the joint F is a roller joint, and all the other points like B, E, D and C are pin joint. In the given condition, system is in static equilibrium where the angles are 60 degree and the length of each segment is 2 meter. We have been asked to find the value of m for this system. However, force value P1 and P2 are also not given. That means we have to find the value of m in terms of these two variables. Now we know that in case of principle of virtual work, we have to displace our system virtually. After the displacement, we should find the displacement of each point where forces are acting, and then we have to write the equation for the virtual work. So now let's solve this problem. As my first job would be to give a virtual displacement to our system, and in the given case I know now the question arises that what sort of virtual displacement. So before I solve the problem, let me explain you that the first condition when we see a problem of virtual work is that how your system will move when you will give displacement to any of the section or point of your given mechanism or system. For example, in this case, if I will give a rotation to this bar A, B and E, maybe in the clockwise direction or in the counterclockwise direction, I can understand that when there will be a rotation to this bar, the other points will get a different position. However, the position of all the other points can be calculated if I know the rotation of this bar. That means all the motions are connected to each other. That means on the other end, if suppose I am giving a certain displacement to the roller joint, for example here I am giving a 1 centimeter displacement to this roller in the downward direction. Do you think that if I will give a rotation of 1 centimeter to this roller, I will be able to get the position of all the other points? Yes. Why? Because the distance are constant between these 2 points which cannot be going to change. At the same time, the roller joint can only move in the vertical direction and the joint A is not going anywhere. The rod can only rotate. That means all the degrees are connected to each other and the system only having a single degree of freedom. This is a system of 1 degree of freedom. In most of the cases, or probably in generally the first year mechanics course, when you will go and study the virtual work, most of the systems are a single degree of freedom system. Now after identifying the degree of freedom of your system, your second job is when you will give a virtual displacement, how would be the configuration of your system after the virtual displacement. For example, this is a scissor kind of mechanism, so I can estimate that if I will give motion to this joint, this point F inwards inside, if I will give a rotation in this way, the point D will go in the forward direction, but at the same time it will also go in the downward direction. Similarly, the point E and point C will also get a configuration which will be below the point C, and point B point will be below this center line. That means after getting the degree of freedom, you should have a visualization so that you can see that how your system is going to get a new configuration when you will give a virtual displacement. The question may be in your mind that the virtual displacement to which point? Don't worry, this is a single degree of freedom system. That means if you will give a virtual displacement to point F, or a rotation to point A, or motion to point E or C or D, the system is going to get only a single configuration because all other degree of freedoms are connected to each other. So without having any delay, I will show you the two different types of virtual displacement, which may be suppose this is my point F and I want to give a virtual displacement to point F in downward direction. If in this figure you can see that this is the picture where this position A, B, C, D, E and F are the initial condition, and I want to give a virtual displacement to this point F. Suppose I am giving a virtual displacement to this point F in the downward direction. So this is my del YF. This is my virtual displacement. As I will give the virtual displacement towards the downward side, this point F will come here, and based on this all the other point will get a different configuration. Suppose, so if I will try to make the position of all the other point, I can understand that this would be the final position of my system. So this is your system after the virtual displacement of point F, and you can see here, because the virtual displacements are always constrained to your system. That means if you are giving a degree of freedom to point F, you are not allowed to give the degree motion in the horizontal direction. Why? Because in the question it is given that the roller joint can only slide in this vertical channel. That means the virtual displacement of point F only will be in the vertical direction. So now this is your displaced condition, and you know that there are three forces: force P1, force P2 and the moment M. That means if you want to write the equation of the work done, you must first understand that what are the motion of all the 3 points. So in case of point F, this is my deflection. Similarly here, if I am giving this is my rotation del theta to the link. Similarly, point D has moved. The point D has moved horizontally. Suppose this is del x D, and point D has also moved in the vertical direction. This is suppose del y D. Now you should see that point D is actually having a force which is in the horizontal direction. So this is the force P1. Similarly, point F is having a force which is force P2, and the rod having a moment which is moment M. This is one of the configuration which can achieve when we will give virtual displacement to point F in the downward direction. On the other end, if I want to give a virtual displacement to the same point, instead of downward direction I want to give a deflection on the upward side. So suppose this is the initial condition for your system. This is your point F. This is point A, B, C, D and E, and I am giving a virtual displacement to this point in the upward direction. So this is my virtual displacement, and again I am writing it as F del Y of point F. So now this is the new position of my point F, and based on this new position, if I will try to make the position of all the other points, this would be my configuration for all the other points. Why? Because you cannot supersede the constraint of your system. You know that this is a scissor kind of mechanism, and if you are moving this point in the upward direction, all the other point will get a configuration which is constrained to each other or dependent to each other. So in this case, my rotation, if you will see the previous case, the rotation is in the clockwise direction, but now I have a rotation which is in the counterclockwise direction, and this is del theta now. Point D has moved. The point D has moved inside with the amount del XD, as well as point D has moved in the upward direction which is del YD. Now after giving the virtual displacement, and please understand that you are going to give virtual displacement either this one or that one. For clarity, I am showing that these would be the two different virtual displacement for your system. After giving the virtual displacement, your next job would be to write the equation for the work done. So let's follow this configuration, and I know that now after giving the virtual displacement, I can see that which are the forces which are giving a virtual work. So here this is the force P1, this is the force P2, and this is the moment M. If I want to consider the reacting force at point A, because it is a pin joint, there will be two reacting force, but we know that point A is a constraint point. Basically after the virtual displacement, point A is not going anywhere. That means these two reactions are not important or will not going to contribute in your virtual work equation. So now my next job will be to write the total virtual work. My total virtual work done will be because of the three forces, and I know that P1 having a displacement which is in the horizontal direction is del XD. If I will write the work done in the vertical direction, but I know that the force is acting in the horizontal direction, and this virtual deflection, downward deflection is just perpendicular to this value, that means the work done will be 0 because the angle between the deflection and the force is 90 degree. However, if I will see this one, because you know that the force is basically what? The work done is basically, I know that the work done is F dot D. That means the dot product means F D cos theta. Theta is basically the angle between the acting force and the deflection. Suppose in my case there is a box, I am giving a force F to this box, and because of the force the box is moving in D direction. That means the force will be F dot D and F D cos 0 degree. In this case, if I will write this value P dot del X, it will be having a cos 0 degree. I saw that I am not writing here, I am just writing P into del X. Similarly, if I will write P1 into del YD, it will be 0, so I am not writing here. Third force will be the P2 into del YF. So this is P1, then P2 into del YF. Third work done will be the rotational work done because of the movement. So here the movement M having a virtual displacement del theta, so my work done because of the movement will be M del theta. If you'll see here, I have not put any sign here. Why? Because after writing these three terms, we can put the sign. So I will request all the students that if you will follow this step, it will be easy for you and this will be less erroneous. Your error level will be low, because this is the force P1 and the deflection is del XD. You know that the force is acting towards the right and your virtual deflection is also towards the right side, so this would be with the positive sign. Second one is the force P2, and you have given a virtual displacement towards the downward side, so this force will also be, this work done will also be positive. But when you will see here that you have given a virtual displacement to this point which is in the downward direction, but your rod is rotating in the clockwise sense. But if you will see the moment M is acting in the counterclockwise direction. That means the direction of the movement and the rotation of the rod are not in the same sense, so this work done will be negative. Now you may think that this virtual displacement is given based on our requirement or by our choice, then why this sign will be positive or negative? So don't worry, if you will write the equation for this case, what will happen? Only the direction, the sense, these three terms will be common here. Only difference will be the sign of the P1 and P2 will become negative and the sign of M will become positive. So I would request that you follow either this free body diagram, this virtual work displacement or this virtual work displacement. It will not make any difference, only the sign will be different. And we know that after writing the total virtual work done, this total virtual work done is going to be 0. Why? Because this is not actual work, this is a virtual work. So this is my equation which is going to give me the unknown value of my moment M. Now my next job would be that this XD, del XD, del YF and del theta are not the single value. So I cannot directly solve this problem. For that I have to, as I already said, that all the degree of freedoms are connected to each other. If you will find the del theta, you will be able to get the value of del Fy, del Yf or del XD, because all the degree of freedoms are connected or the geometry of system is known to you. That means you can replace any of these terms with respect to the other term. So how we can do that? This is very important step to solve the problem, and you should see very carefully. As you know that you are interested to find the deflection of this point, you are interested to find the deflection of this point and the rotation of this rod. So we are going to make our original configuration. This is your displaced configuration, this is your original configuration. So here again I am going to make the original configuration, and you know the length of this section is 2 meter, 2 meter and 2 meter, and all the angles are given as 60 degree. So your job will be to, if you will see here, you have perturbed or give variation or displacement to your system, and you are interested to find the displacement of point D, displacement of point F and rotation of this rod. In case of virtual work, when you give a virtual work, basically you give a variation to your system. And in this case, if I know the coordinate of my point D, I am giving a variation to coordinate of point D. That means the change in the coordinate of point D will be the displacement of point D. So I am going to write the coordinate of point D. But you know, when I want to write the coordinate of point D, first I have to define a reference point. My reference point would always be the fixed point which is not going to change. In this case, A is the fixed point, so A will be my reference point. And when I am writing the coordinate of point D with respect to A, it will be basically, this is theta degree, theta and theta. So if I will write the distance of point D is this total distance. And the total distance will be the cos component of this part and this part. So it will be basically 2 cos theta, then 2 cos theta, then 2 cos theta. So the coordinate of point D will be basically 6 cos theta. Similarly, if I want to write, I am interested to find the deformation or the virtual displacement of this point, I have to write the y coordinate of point F, which will be the sine component of this. So it will be basically 2 sin theta plus 2 sin theta, it will be 4 sin theta. Now the third is the already in terms of theta, so I am not going to write the coordinate or anything for this. Now my job is to, I am interested to find the value of del xd. That means I am going to apply this delta. Delta is nothing but the variation to the coordinate of d, and the variation is nothing but the first derivative. So I have to differentiate this term. So I am going to get that del xd will be 6 sin theta del theta with a negative sign. Similarly, my del yf will be 4 cos theta del theta. Please understand, this is what basically you can remember this as a step by step, but I just want to give you the detail that how you are going to get this del values. Earlier you are having this point and you know the coordinate of these 2 points. After getting the coordinates, you are perturbing your system or giving a virtual displacement to your system, and virtual displacement is so small, that means it is a variation in your system, and this del basically represent the variation. When you will see books, sometime you may find that they use this variation term. Variation term is basically the change in your coordinate or anything, and that can be calculated by getting the first derivative of your respective coordinate. So in this case, these are the 2 coordinate and this would be the final value. When I will put this value back to my equation, I will get an expression. That expression will be defined by this term. Here you can see that this is 6 sin theta. Please remember, here again an important point. If you will see that this value, this is coming out negative. But please remember, I am not going to use this negative sign. I am going to use the absolute value of this del y. Why? Because these signs are already defined based on the motion of the point. And as I told you that if you will give the sign at this stage, that will help you to reduce your error, and when you will get the variational value or the variation in the coordinate, you no need to put the sign again. If you will going and use the same sign here, the term will change again, and that we don't want. So once you will decide you will fix your sign at this stage, after that you are going to only use the absolute value of these 2 terms. So when you will put back these 2 values, you are not going to use this negative sign. I am again repeating for all the students, we will get the derivative, but after getting the derivative, we are going to use the absolute value of the variational value. So when I am going to put this value back here, this would be my expression where P1, which was a positive value, this is your basically the del xd. Similarly, P2, this value is your del yf, and this is your m del theta. Now you can see here that the del theta is common term, so I can remove, and finally when I will rearrange, this will be the value of moment. So in that way we can solve the problem of virtual work. So I am just summarizing that this is your actual problem. After giving a virtual displacement to your problem, first you will write the work done equation. After writing the work done equation, you will see the equation. There are 3 terms which are not known to you, but you know that these degrees of freedom are connected to each other. So you will go back to your original configuration, and then you will write the coordinate of your point of interest. I can write the coordinate of these points, but there is no force, so I am not interested. these are the coordinate. After writing the coordinate, you have to give variation. Variation means you have to give the first derivative. You have to find the first derivative. This is my first derivative for this coordinate and first derivative for this coordinate. However, the negative sign is coming here, but I have already put sign at this stage when I am writing my work done. So I am not going to use this sign. I am just going to use only the absolute value, and after putting the absolute value, I am getting my final answer. So my moment will be this value, which is in terms of these two variables P1 and P2. Thank you.